This training module will provide a review of the rules regarding electric utility pole climbing space for the most common types of overhead line construction as set forth in Section 54 of the California Public Utilities Commission's General Order 95, Rules for Overhead Electric Line Construction. Part 1 will cover the pole-centered climbing space rules for wooden line arms and low-voltage cable construction. Part 2 will review for quadrant climbing space for buck arm construction. Part 3 will provide an overview of allowable climbing space obstructions. As a utility professional responsible for the design, planning, and construction of overhead utility poles, it is critical that you understand the rules regarding the pole climbing spaces utilized by designated line workers to safely ascend and descend utility poles. Safety is everyone's responsibility. According to the California Public Utilities Commission,
Climbing space means the space reserved along the surface of a climbable pole or structure to permit ready access for linemen to equipment and conductors located on the pole or structure. Climbing space shall be maintained from the ground level.
in this training module, we'll be discussing line arms, buck arms, and low-voltage cable construction. Shown in this profile view, line arms are cross arms typically installed at the top of a pole. High-voltage conductors, shown in red, are attached to the line arms using electric insulators. For clarity within this training module, the high-voltage conductors attached to cross arms will generally not be shown. Buck arms are cross arms that are typically installed below and perpendicular to line arms as shown. Low-voltage cable is attached to the pole below both line and buck arms. Shown in this top-down view, you can see the line arm attached to one side of the pole along with the conductor insulators. Installed below and perpendicular to the line arm is the buck arm, and when present, secondary cable is attached to the pole below, both the line and buck arm as shown. Let's begin with pole-centered climbing for line arms and cable construction. The electric utility pole shown on the right is comprised of a single wooden line arm. That wooden line arm is installed at the 12 o'clock position on the pole, as shown in the top-down view. The general order states,
Where a single level of circuitry is installed at the top of a pole, the climbing space shall extend up to the level of such pole-top circuitry and need not be provided through and above such level.
shown in the top-down view, the climbing space could be designated and illustrated in a number of locations on this pole, since there are no obstructions present on the pole. It is the engineering designer's responsibility to ensure that there is at least one unobstructed climbing path from the ground to the top of the pole that meets the guidelines set forth in the general order. For this example, we'll keep our climbing space shown at the 6 o'clock position. The climbing space is centered on one side or face of the pole. We'll refer to this as pole-centered climbing. And as shown on the right, this climbing space is maintained from the ground to the top of the pole. This is the obstruction-free zone through which our line worker will ascend the pole. According to the general order, for pole-centered climbing, the dimension of the required climbing space will vary upon the voltage of each level through which the line worker needs to climb. Voltage levels up to 7,500 volts will require a climbing space which shall be a square, 30 inches by 30 inches in size. This climbing space, shown at the right, will be centered on one side of the pole as shown. Levels up to 46,000 volts will require a 36-inch square climbing space. Voltage levels above 46,000 will require an additional 1/2 inch per kilovolt above 46,000 volts. Let's take a look at an example. The pole shown at the right is made up of a 12 kilovolt line arm at the top of the pole, a lower 12 kilovolt line arm, and a secondary level of overhead cable with a voltage of 240 volts. The climbing space through the secondary level shall be a square 30 inches in size, located in the 3 o'clock position on the side of the pole opposite the attached energized conductor. Also, according to the general order,
The climbing space shall be maintained in the same position of not less than 4 feet vertically, both above and below each conductor level.
this area shown at the right should provide adequate room for the lineman to safely ascend and descend through the secondary level without risk of fall or contact with energized conductor. The lower primary level, being of higher voltage than the secondary level, will require a larger 36-inch climbing space located in the 6 o'clock position on the side of the pole opposite the attached line arm. And similarly, this climbing space should extend 4 feet above and 4 feet below this voltage level. This area should also provide adequate room for the line worker to safely ascend and descend the pole through this voltage level. You'll note that the climbing space through the lower line arm requires the line worker to climb through the primary conductors. A typical 10-foot line arm, shown below, has the inner pin positions located approximately 4 feet apart. This 4-foot conductor separation should provide adequate clearance for the required 36-inch climbing space. When installing line arms of different sizes, it's important to note the distance between conductors installed on the inner pin position to determine if climbing space requirements are met. You'll also note that the first climbing space was a 30-inch square located in the 3 o'clock position on the side of the pole opposite the secondary conductor attachment. And our second climbing space through the lower primary level was a 36-inch square located in the 6 o'clock position on the side of the pole opposite the lower line arm. This change in position of the climbing space will require the line worker to rotate on the pole. According to the general order,
Where the vertical distance between conductor levels is 4 feet or more, the position of the climbing space may be shifted not more than 1/4 of the distance around the pole.
in other words, this shift in climbing space is permitted under the rules as long as it does not require the line worker to rotate more than 1/4 of a turn on the pole. The pole-centered climbing that we've discussed up to this point also applies when buck arms are installed on the pole, as shown on the right. In fact, the general order states,
Where the vertical clearance between conductors on line and buck arms is 4 feet or more, the climbing space shall be provided on one side or face of the pole for each arm.
in other words, when separated by 4 feet or more, line workers are able to ascend the pole utilizing a pole-centered climbing space and then rotating 1/4 turn between the line and buck arm and continuing the ascent to the top of the pole. However, when line and buck arms are separated by less than 4 feet, the general order states,
The climbing space shall be provided through such levels and located in a quadrant.
that brings us to section 2 of this module. Quadrant climbing for buck arms. Up to this point, we've discussed pole-centered climbing spaces as shown in the top-down image. Quadrant climbing shifts this climbing space laterally into one of 4 positions similar to the quadrants of a Cartesian plane. Also, when utilizing quadrant climbing through voltages up to 46,000 volts, the general order increases the dimension of the required climbing area to 42 inches. This climbing space can be located in any of the 4 quadrants located on the pole. Note that the orientation of any quadrant is relative to the orientation of the line and buck arms as shown. When the line and buck arms are separated by less than 4 feet, quadrant climbing allows the line worker to ascend the pole through both the buck arm and the associated line arm by climbing within the designated quadrant and without the need to rotate on the pole. However, in order to climb through the attached conductors, sufficient clearances must be met to allow for the 42-inch climbing space required. We've already seen when utilizing a pole-centered climbing space, sufficient clearance between conductors can easily be achieved with a typical 10-foot cross arm as shown. Whether 4 wires or 3 are installed on the line arm, the pole-centered climbing space is unaffected. However, when quadrant climbing through both the buck arm and line arm, the line worker will need to ascend through 2 levels of conductors. When 3 wires are installed on the line and buck arms as shown, only 1 quadrant is available for climbing. When 4 wires are installed on the line or buck arm, none of the quadrants are safe for climbing because the conductors encroach in all of the available quadrants. When this is the case, the line and buck arm should be separated by 4 feet or more, so pole-centered climbing and rotating can be utilized. If this is not possible, longer cross arms should be installed with sufficient spacing between the inner pin positions so the conductors do not encroach into the quadrant climbing space. Quadrant climbing can also be utilized when climbing through low-voltage secondary cable, when service drops or conductor branches are present that encroach into the pole-centered climbing space. Shifting the pole-centered climbing space to a quadrant location can provide an obstruction-free climbing space through which the line worker can ascend. You'll note in our previous example, in some locations the cross arms installed on the pole encroach into the designated climbing space as shown in the image. The general order does allow for some obstructions within the climbing space. That brings us to the final section of this module, allowable climbing space obstructions. The general order currently permits 10 specific obstructions within the climbing space. As we've seen, cross arms and their supporting members are allowed within the climbing space. Supporting members include the brackets, V-braces, or Hubbard braces that support the cross arm. Cross arms most commonly encroach within the climbing space when double cross arms are installed on the pole, as shown at the right. Insulators and their attaching brackets, shown at the right, may extend 1/2 of their diameter into the climbing space. This is most common when the spacing on the inner pin position is the same as the required climbing space dimension, and correspondingly, conductors may extend 1/2 of their diameter into the climbing space. One of the following may be installed in any 4-foot section of climbing space: suitably protected vertical risers covered by wood, ground wires covered by wood, or ground wires covered by plastic no greater than 1/2 inch in diameter. Up to 2-guy wires, similar to the one shown in the image at the right, not contacting metal pins, and having a vertical separation of not more than 18 inches vertically, may be installed in any 4-foot section of climbing space. Streetlight brackets, similar to the ones shown in the image at the right, may extend 1/2 of their diameter into the climbing space. Operating rods for gang-operated switches, as shown in the image, may extend 1/2 of their diameter into the climbing space. Some utility pole bands used to attach conductor or equipment to poles and limited to 6 inches in width are allowed in any 24-inch section of climbing space. Some pole restoration material is allowed, provided pole steps are placed in the restoration area. The bolts and washers used to attach equipment and cross arms to poles, some needing to be covered and some not, are allowed. Refer to the general order for a complete list of allowable climbing space obstruction requirements and exceptions. Also note that even though the obstructions listed are allowed, the general order states,
Reasonable efforts shall be made to avoid installing the above-listed allowable obstructions within the climbing space.
the safety of the men and women line workers who will need to climb these poles is of utmost importance. That brings us to the end of Part 3 of this training module. We hope after watching this training module on the rules of climbing space, as described in the CPUC General Order 95, you now have a better understanding of pole-centered climbing spaces for wooden line arms and low-voltage cable construction, the use of quadrant climbing spaces for buck arms, low-voltage services and branches, and an understanding of the 10 allowable obstructions within designated climbing spaces. Take time to review the rules within the general order and refer to www.cpuc.ca.gov for updates. Thanks for watching and climb safe.